for their presentation. They have kept the timing, well in mind. So I expect the same from the rest of the presenters now on to follow the same pattern. The floor is yours, Professor Mainak. You may go ahead.
Thank you.
Kindly open your presentation.
Yeah. Is it visible? No.
It's uploading. It's opening. Yeah. Now it's. Yes, you can go to the slideshow and start presenting.
Environmental remediation for 70 TS system using titanium nanocomposite. This is my paper topic. Session 13A. Myself, Moina Ghoshal from IIT Shibpur, West Bengal, a autonomous government organization. Now, what is the agenda today? I am indebted to the organizer for giving me the chance to present. Background, I will be sharing what is concrete durability, role of nanomaterials like nanotitanium calcium in concrete durability, our research, results and discussion and conclusion. Now, background, if you see the background, yeah, you see the background, this is a World Economic Forum, but I am not getting my picture, I am only getting the screen. Is it okay?
It is visible, sir. You are audible also. You may proceed.
Okay. So top 10 risks over the next 10 years as identified by WEF, World Economic Forum. Out of this top 10, 5 major risks falls in the environment chapter. There are like extreme weather, climate action failure, natural disasters, biodiversity losses, human-made environmental disasters, all fall in the environment chapter. And you see Environmental Protection Agency of United States, they say the industry, cement industry comes first, followed by the steel industry, are the third party or the third ranked responsible for the greenhouse gas emissions all over the world, global. Now you see the market share of the construction steel in different countries. You see Japan is using construction steel 40%, Australia 50%, US 60%, UK 80%, but India, we are lagging, we are using steel up to 10%. This information I got from a webinar organized by Institute of Engineers supported by National Skill Development Forum in January 2021. And so our emphasis are on the cement and concrete mainly, and so the greenhouse now we come to the self-healing materials, and is it durable is a topic. Is it durable? The Global Agenda Council's 2014 and the World Economic Forum says self-healing material as the #1 priority emerging technology. No, so, but concrete durability, what is concrete durability? Different organizations have given concrete durability different way. American Concrete Institute says in a different way. Indian IS 456 says in a different way. A durable concrete is the one which performs satisfactorily in the working environment during its ultimate exposure condition. As per IS 456, durability of concrete is steps to resist weather reaction, chemical attack, abrasion. As per ACI, so when exposed to environment, durable concrete is likely to retain its original form, quality, stability in lifetime. These are the different definitions as per different organizations. Now, sulfate and chloride attack are the chemical attacks on which a durable concrete rests. See, chloride ions come from the seawater, and sulfate ions comes mainly from the inland. Though seawater contains some sulfate ions, and we know India is a coastal country. So these are the parameters on which the durability or of the system concrete system depends. Or built material. Now, if you see the parameters, then we come to the cement part. Now, you see the hydrogen of cement, OPC, organic portable cement plus water. Yes, with water gives CSA gel, the calcium silicate hydrate gel, which is responsible for the strength of the system or built environment, and it produces calcium hydroxide. Now, which is the treacherous thing, and it attacks. It gets attacked by the external environment, like external chemicals like chloride and sulfur I was telling. Now, cement hydrogen also had its peculiar properties. We as in India or many other standards follow a 28-day strength, but cement hydrogen continues beyond the 28-day strength, and our paper discusses all these things coming. Sulfate attack, chemical reactions, calcium hydroxide I told you, it reacts with the magnesium and sodium sulfate, producing secondary gypsum, calcium silicate hydrate, calcium sulfate. And calcium sulfate, it reacts with the cement particle tricalcium aluminate, which presents the cement phase, and it produces ettringite. And which imposes ettringite with water component remaining. Now this is a mechanism, calcium sulfate, secondary gypsum, this is hydrated calcium aluminate of the cement, and it produces the concrete ettringite, which is a crystalline in form and which disintegrates the concrete when it expands. Tears open the concrete, and the sulfuride edge formation, signs of sulfuride including cracking and expansion, damage starts at edges and corners, extended crystal formation, deposits in the cracks, what is happening on the surface, where mainly in the inland and also coastal due to the presence of these things. Chemical reaction is a deformation, expansion mechanism, crystallized pressure theory and swelling theory. Now good, this is a picture showing how it penetrates the sulfate, it attacks the concrete, it reaches the reinforcement, and this is a type of reinforcement we get in the sulfate attack. Now chloride attack, calcium hydroxide I already told you reacts with the sodium chloride and it produces calcium chloride and it's sodium hydroxide. And this calcium chloride, it reacts with the tricalcium aluminate with the cement, and it produces calcium chloride aluminate with presence of water, 10H2O. This water I will come in later. The mechanism calcium chloride formation, which is crystalline in nature. And this 40% of the contribution of failures of the concrete structure is due to this chloride attack. It's corrosive reinforcement, where mainly coastal areas, chemical reaction, calcium, this filial salt formation, expansion, it expands, crystallizes in pressure theory, and it swells and it tears open the concrete also. Now, this is a schematic diagram. This chloride solution, it enters the concrete, reaches the river, destroys the passive layer, and see, this is the type of corrosion when it will get. Now, self-healing nanotitanium dioxide, this is my today's topic, plays a vital role in the durability of the concrete. How? This is a paper from Habibi, Yangji, Ajit, et al. It says this nanotitanium dioxide oxidizes bacteria, organic molecules, and also viruses also. There's COVID virus also. This is a paper, 2020 paper, Journal of Colloid and Interface Science. You can see in the left hand side. Now, how this video will tell you how.
This video will demonstrate the mechanism and principles of photocatalysis. In photocatalysis, when light energy is irradiated from the sun or other fluorescent lighting onto titanium dioxide, a strong power of decomposition is generated on the titanium dioxide coated surface. Because of its properties, microorganisms and viruses are continuously decomposed until they become harmless. The effect of photocatalysis is almost permanent. Let's look at how this works. When light energy is irradiated onto the surface of titanium dioxide, electrons are released. The released electrons bind with oxygen to become superoxide anion. The surface of the titanium dioxide becomes positively charged and takes electrons from moisture in the air. The moisture in the air that has lost electrons becomes hydroxyl radical. The hydroxyl radical is often referred to as the detergent of the troposphere because it reacts with many pollutants, decomposing them through cracking, often acting as the first step to their removal. The superoxide anion and hydroxyl radicals, by their power of oxidation destruction, decompose organic compounds such as COVID-19, unwanted bacteria, H1N1.
Now, what is nano? You see, nano is a very 10 to the power minus 9 site. You see this video?
You have a sense of scale. These are things you can see with your eye. I love this visualization because you start to move in. You start to see quickly go beyond the resolution of the human eye and start to go into the bigger cells like the amoeba, which you might remember from biology, the paramecium, some of the larger cells like the human egg. And you start moving into the smaller scales. This is a micron scale. This is bacteria, mitochondria that powers our cells. And now you start moving into the nanoscale, the virus.
Now how nano? This is a Benjamin Franklin letter which says, I saw I fetch a drop of oil on the water, and as you know, oil is immiscible in water. But amazingly, the oil spread, and gradually up to the quarter of a point, half an acre, it spread. So the fundamental thing is, as per the nanoparticles present in the oil, it spread to that power, half an acre, quarter of a point spread. This one drop of oil. Why nano? Say one cube, you break it into 4 parts. Say this is a cube, you break it into 9 parts. No. If you break this cube one face into 3 into 3 9, you say how many cubes you can get. Such is the power of nano. You disintegrate, you get more space. Like we have in our cement, more space means more hydration of the cement. More hydration of the cement means more hydrogen product, more strength. These are main basic fundamentals of this nano. Now Indians used nanotechnology 2000 years ago. This is a paper from Mumbai Mirror, and this has been proved by Robert Karl Jr., who got Nobel Prize in the 1990s era for his now excellent self properties improve the incomplete strength of cement and concrete will come later. This is self-cleaning glass of dielectric dioxide. It's a conventional glass we use. Now see how dirt falls, and dielectric dioxide present in the glass can oxidize the dirt with the help of water. Now these are some papers which says the dielectric oxide can be recovered from paint waste of lignocellulose materials, and waste and also fruit peel, agro waste extracts. It can be synthesized from waste. Application of nitrogen dioxide, coatings and fabrications. These are some coatings example of Pacific Museum, Rome, Fort Bridge, Stadium, Olympic Stadium, London, Terminal, Japan. All are used nano coatings. Now these are some fabrication of buildings that first Rome 1996. Then came France Architecture 2001, Hotel in France 2003, Hospital in Mexico 2013, Definitely in Turkey 2014. All have fabricated using nanotitanium dioxide. They are performing well. World research nanotitanium dioxide, you see China and mainly China and North America and APEC countries are using. In Asia, mainly these people are using in globe, and Asia only China and Japan are mainly using this. Now my research or our research, these are my pictures I have taken from the research. Heat testing machine, these are the exposure in magnesium chloride and magnesium sulfate solution. These are see conventional cube, blackish or grayish nature, and the cubes using nanotitanium dioxide is white in color. These are our nanotitanium dioxide I got from Kerala Mines and Minerals Limited. These are admixture PC polycarbonate ether I have used in the, and this is your ultrasonic vibration machine for the dissolving of the nanotitanium coming later. How mixing, you cement mix plus nanotitanium dioxide, it doesn't mix with water, it is immiscible in water, it doesn't mix. So what happens, I am using ultrasonic vibrators from our lab, then I am giving the ultrasonic energy to break open the...
Professor Ghoshal,
yeah.
Professor Ghoshal, last 3 minutes for you.
Okay. Now exposure in magnesium I have exposed in diffuse sunlight. In diffuse sunlight is giving such a good result. Test results I'm coming. The properties is a crystalline property. You see the multi-phase crystallinity, and is of average particle size 30 to 40 nanometer. Not going to detail, we have no time. Test results. See, you have 1%. You see the increase in 28 days, 12.59% increase. 360 1 year. I'm getting 37.15% increase for 1% nanotitanium dioxide. More titanium dioxide, I'm not getting this is black one. I'm not getting so much good result because of agglomeration of this nanoparticles. There are some problems, inherent problems. Now this is a bulk density. You see the increase in bulk density of pod using 1% nanotitanium dioxide. For the more I'm not getting the agglomeration. I'm getting agglomeration. Yeah. These are the stages for our mortar cement and preparation. See on it, and it increased. And last stage 1 year it increased by 37%, which is in the reference sample, ordinary mortar sample. Result in magnesium chloride. See 90 days it is not increasing, decreasing, but at a later stage it is increasing 49.36%. This is 1% the optimized % of nanotitanium dioxide, 49.36% increase, and in MDSO4 90 days it is not getting good result, but 180 days, 60 days is giving 64% with respect to the reference sample. Yeah. Now conclusion, steel reduction needs to shift focus to high performance cement concrete, at least in India, because we are not using steel so much in the construction area. Second thing, research confirms that 1% optimized addition of nitrogen dioxide, and our work shows this dosage performs well in concrete under aggressive environments like magnesium chloride and natrium sulfate and chloride and sulfate ions. Nanotechnology is in India is underdeveloped in countries like US, Japan, Europe, or even China. I have shown that slide. Issues related to the environment needs initiatives not only at the policy level, but significant action needs to be implemented at the micro-built environment level. Every individual, institution, organization needs to curb wastage as a social parameter, a social responsibility of all forms of energy and protecting the built environment through nano applications. This is my conclusion. See, you have to apply nano. See, it is more durable, it is more workable, it is more chemically resistant, it is giving superior finish. You don't have to add paint, it is what is in color, it is a green product, can synthesize from waste. But still, we are lagging. Thank you. Any question?
Thank you, Professor Ghoshal, for giving us in-depth knowledge about the environmental remediation for cementitious systems using titanium nano composites. And it's a path-breaking and it's a future-oriented presentation which you have given to us. And I'm sure the industry is going to adopt. Industry is going to adopt more and more, this kind of technique in the coming times and shift their focus from the conventional to the new, these suggestions which you have just mentioned in your presentation. So thank you once again.
The university has given me an award for best research in these nanoparticles.
That's wonderful, sir. We look forward for more awards. We look forward and we wish that you achieve more awards. And this is, as I said, it's a groundbreaking, kind of revelation to the industry. And I'm sure the adoption will be more faster in the coming times. So thank you once again.
Thank you, sir.
Again for this wonderful presentation. Next, I would request Professor Ghoshal to stop sharing the screen so that we can move to the next presenter. Yeah. So next in line is Mr. Virat Khanna, who is going to speak on fabrication of graphene nanoplatelets, reinforced aluminium matrix nanocomposites for strength enhancement applications. Kindly proceed, Mr. Khanna.
Audible?